Hello. This video begins a new playlist on current mirrors. But before we begin current mirrors, there are a few things we need to understand about current sources. First of all, let's see the application of current sources. We are already used to current source being used in this way. In an attempt to get the intrinsic gain of the device rather than placing a resistor here. So we see that this particular current source draws current from the source VCC into a particular node. In this particular scenario, the node is a collector node. So I'll just represent this type of current source like this. Then we are also used to another type of current source where we have a node like the emitter node. Then this time the current source is drawing current from that node to the ground. So this is the highest possible value of degeneration you can obtain if you remember your cascode devices from the previous playlist. So let's represent this particular node this way, type of current source where it draws current from a node into the ground. Now this type of current source use PNP devices, so we can call them P-type current source. And these ones use the NPN devices. We can call them the N-type current source, which we are very much used to. So let's see how a PNP device works. So it works on the same principle as the NPN device. A thin base. So this is the NPN that we are used to, and this is a PNP. Okay, with a highly doped emitter and a highly doped emitter here as well. So the same condition for forward active mode. The base emitter junction should be forward biased as we are used to here. So this junction also has to be forward biased. Now if this junction has to be forward biased, then it means that the P type here has to be more positive than the N type here by at least 0.7, or we know the range right from 0.5 up to 0.8 to get something reasonable. And the same scenario, when it's forward biased, the current will push electrons into the emitter, and the ratio 1 to beta will cause beta times holes to push into the collector. So we see that the flow of current this time is going to be from the emitter to the collector. So basically this is how we represent an NPN device, sorry, PNP device. If this is the VCC, let's say 5 volts, we want to connect the PNP device this way. So this is a P-type region, N base, and P-type, and we put the arrow facing towards the base. So assuming this is 5 volts, and I want to bias the base emitter junction. So this is the base, this is the emitter, and this is the collector. So we shouldn't get confused. The base, the emitter pin always has the arrow. And let's say we are used to 0.7. So So we put 0.7 here, and the emitter is tied to the 5 volts on top here. What is going to be the base emitter junction? But here we call it the emitter base junction because the emitter has the higher potential as compared to the base. Is it forward bias? That's the first question. Yes, because the emitter is more positive than the base. But the base emitter junction is not going to be 0.7, but rather going to be 5 volts for the emitter minus 0.7 at the base. And that's going to be 4.3 volts. So the collector current is going to be 26. Okay, so supposing the transistor we are using has IS to be 10 raised to the power negative 14, then we are going to get a very huge value of current, which is not desired. So there's something that we need to fix here. So obviously this cannot be 0.7, rather it has to be 4.3 volts, and that will make our emitter base junction forward bias by 0.7 volts, and we get reasonable current through the collector. Okay, so at least we've learned something about the PNP junction used as a current source. So if you wanted to replace this device, we wanted to replace the ideal current source with real current sources, then it means we are going to have a PN device on top here, and if we wanted to cascode that one, we will have this device being degenerated by this device, because the second device Q2 is connected to the emitter of Q1. Then comes the transistor, so we can take the output from here. Then we have Q3, and another transistor Q4. Okay, so assuming we wanted to put a current source behind and beneath transistor Q3, which is taking in the signal, then in that case we would have something like this. So this time it has to be NPN. Transistor. Alright, so current mirrors will let us see how we would bias the current sources in this device. So until then, see you. Bye.